Today, it's been a great honor for me to present our work in representation of my co-authors, Zhiyuan and Fenggui. And I have to apologize for our absence for not being there at the conference, but still I'm going to present it remotely. Thank you for your patience. And our paper theme is about enlivening performance art, enhanced interactivity through embodied cognition and real-time physical visualization on swarm tangible interfaces. It's a bit abstract, so we may start from the cases of tangible interfaces for ubiquitous computing. As we can see, there are many kinds of forms of tangible interfaces, like the hermit. It's tangible interfaces on the tabletop. Like Herman, they explored a modular system for the tabletop where the robots offering a variety of interactive functionality. One of the applications of which is to serve as the storytelling system on the table. And then another case is also the tools on table, but the work disappeared. Unlike the previous one, it further explored a more interactive possibility for the tangible interfaces in a more vertical space. And then, as we can see, this case used the wriggling swarm robotics on the ceilings for a more for the spatial interaction as actuated tools. Yeah, it's on the ceiling. And like these two cases, Rovable and Embodied mobile tools to develop the application scenario, including the embodied sensing, modular display, tactile feedback, and also interactive closing. And this one, also this one, SkinBot, explore the form of tangible interface on our human skin surface. So overall, these all kinds of tangible interfaces in our everyday space, including ceilings, tables, clothes, and even Embodied, all of them has depicted as a scenario where the space has gradually merged into a whole. However, we can see the unified trend, but all of the tools, it seems, still scattered around the space, and our human living this space have to dynamically adjust ourselves to adapt ourselves to their interactive modalities. So we have to ask, is it possible to have a form link all those slices of space together? Accordingly, based on our imagination, we extend the flexible surface climbing capability of Rovable to a larger 3D-dimensional space. So we introduced our previous work, Link.io, tangible interfaces as a bridge. It's a kind of tangible interface modified from a flexible closed climbing structure with magnetic wheels. It's an open source project modified from MIT Rovable team. We hope they could serve as a bridge over the separate space. As we can see in the diagram, we modified the structure to better support its vertical surface climbing capability, which is rather important for our space linking scenario. And we experiment a lot of kinds of wheels with the fairing structure, with the fairing surface texture in order to adapt to our need to move the tools on a more vertical and flexible surface. On the other hand, we try to use some microcontrollers, drivers, component, which is available at low prices, and rather than a complicated custom PCB board, our deployment with ESP32 has significantly lowered the threshold for learning and deployment for artists and designers like us. And here, come back to the theme today: human-robot collaborative performance. I have to clarify a pre-concept, joint action performance, which means your bodies and move. Which means your body and moves moving together to achieve collaboration, but with inner coherence between the robotics and human performance. For instance, like the case box, it shows us a collaboration between human and robotics arms to produce an illusionary stage performance as an attempt for the computer to understand humans' intention and to better achieve the joint action performance. In another case, training space, investigate the alternation of human spatial perception through the control of swarm robotics, whereas it's more like a prearranged performance rather than the improvising one. So from this case, we can see, although this work in the realm of human-robot collaborative performance has already made some attempt in the pursuit of better joint action performance, we found them still cannot fully achieve the what we call the inner coherence, both spatially and temporally in live performance. Thus, to probing the both aspect of coherence in live performance, we accordingly introduce both Link.io and another approach of physical visualization to the realm of live performance. Like what was shown in the left, the unified form of tangible interfaces provides us with a more natural flow and continuous movement for the spatial coherence. And whereas we hope the form of physical visualization, which enable us to better perceive the location and motion of the swarm robotics, to provide our human performers with the real-time feedback and in the pursuit of synchronization for the better temporal coherence. Based on our scenario, we design and tested our interactive pipeline architecture. Like shown in the diagram, we utilize the Wi-Fi capability of the microcontroller ESP32 for the communication between the swarm robotics and the server, and also use OpenCV ArUco marker for the real-time recognition of the position and poses of the tangible interfaces. And also, after the recognition, we then project the recognized result back to the canvas, and each individual swarm robot project the pattern back to it. So as we can see, we further develop the varying forms of the creative expression in the for the physical visualization. Like we experimented with different styles of particle effect in open processing community. We also tried the real-time image-to-image generative AI model, like stream diffusion, to test the effect of real-time image style transfer. So So you can see the four kinds of demo we have already tried. And here it shows the demonstration. Our interactive framework was tested in the live performance in the campus of China Academy of Art. And here is a short video for demonstration. Yeah, that is. Thank you for your patience, and I'm glad to answer any kind of questions.